Good afternoon. We are doing radical division. So division of dividing radicals. Not too terribly hard, I hope you don't think. Things you need to know. Well, if the index numbers are the same, you can reduce what's inside those radicals just like you do a normal fraction. So in the case of this problem, I recognize that 3 divides into both 3 and 27. So that leaves me with the square root of 1 over the square root of 9, which equals, well, what is the square root of 9? 1. 1. What's the square root of 9? 3. So 1/3 is my answer. Over here on the second problem, once again, their index numbers are the same. So I can take this 2 and divide it evenly up here into this 6, leaving me a 3. So my answer is the square root of 3 over the square root of 1, which is the square root of 3 over 1. And normally we don't leave a 1 in the denominator. We don't write it, so this answer is just the square root of 3. On our next problem, if your numbers out in front, those coefficients of your radicals, can be reduced, you would reduce those because outsides to outsides, insides to insides. But the 5 and the 2 don't reduce, so we're going to ignore them for the moment. And I recognize that 10 is divisible by 5 and 125 is divisible by 5. So what I end up with is 5 square root of 2 over 2 square root of 25. Well, ladies and gentlemen, we know what the square root of 25 is. That's 5 square root of 2 on top, and that becomes 2 times, well, the square root of 25 is 5. So that goes on the bottom. And look here, I've got a 5 and a 5, and guess what? They cancel, or to help me reduce, so this answer is square root of 2 over 2. Now the square root of 2 on top and the 2 on the bottom cannot be reduced because one's inside a radical and one is not. And as we've talked about in the past, they must both be in the same location. So inside to insides, outside to outsides. All right, here we go again. This 2 and this 5 on the outside cannot reduce them, but I look at the insides and I see that 5 and 10 will reduce, leaving me a 2 on top and a 1 on bottom. So my answer ends up being 2 square root of 2 over 5, because the square root of 1 is 1 and 1 times 5 is 5. All right. Let's look at cube roots now. I have the cube root of 27 and the cube root of 8. If you don't, and I don't expect you to, but you should start to be recognizing some of your perfect cubes. So if you don't recognize it, you would go ahead and make a factor tree. So 3 and 9 and 3 and 3. Well, since I have 3 and I'm grouping by 3s, so I have 3 3s, that means 1 comes out, the other 2 meet their demise, and there's nothing left inside my pleasant prison. So nothing's in prison. We move on to the second one. If you don't recognize 2 as a perfect cube, you would go ahead and factor tree it. And then you would see that you have 3 2s. And since we're grouping by 3s, my 2s get to break out of prison. 1 survives. The other 2 meet their demise. So 3 halves is my answer. On the 4th root of 8 and the 4th root of 1,250, I first tried to divide 1,250 by 8, and that didn't work. Then I tried to divide 1,250 by 4, since that is a factor of 8, and that didn't work. So then I divided both the 1,250 by 2. So I can reduce this by 2 for both of them. So I end up with the 4th root of 4 on top and the 4th root of 625 on the bottom. But I need to try to factor tree 625 to see if I can group anything in groups of 4. So when I do that, I find out I have 25 times 25. And then I find out that 25 is 5 times 5. And 25 is 5 times 5. And lo and behold, I have 4 5s. So my 5s break out of prison, leaving me 1 in the denominator, and the other 3 meet their demise. Last slide. I look at the coefficients out here in front, this 3 and this 2. They don't reduce. I cannot reduce these guys. Now, if I could have, I would, because outside to outside, inside to inside. But since I can't reduce them, I go ahead and I look at 4 and 243. Well, there's nothing that divides evenly into both 4 and 243. So the next thing I do is I say, okay, let's see if I can factor tree and get anything that could possibly group in groups of 5. So I start with 243 and it's divisible by 3 and I get 81, which we know is 9 and 9, and 9 is 3 and 3, and the other 9 gives me, of course, a 3 and a 3. And lo and behold, I have 5 3s, so I get to make a group with those. So on top I have my 3, 5th root of 4. And on the bottom I end up with 2 times 3, because they all break out of prison, one survives, the other 4 meet their demise. And then I recognize that, oh, look at that, my 3's will cancel, so my answer ends up being the 5th root of 4 over 2. All right, last problem. Once again, I look at my coefficients, the 5 and the 4 on the outside. My 2 outside numbers do not reduce, and since they do not reduce, I just ignore them for right now. My 3 only breaks up as a 3, so nothing's going to happen in my numerator. And then I look at my denominator. Well, 64 is 8 and 8, which is 2 and 4, which is 2 and 2. And I end up with the other 8 doing the exact same thing, of course. So I have 2 groups of 3 2s. So I have a group here, and I have a group here. So out of each group, one will survive, the others will meet their demise. So 2 times 2 is 4. So my answer ends up being 5 times the cube root of 3 over 16. So now remember, outsides to outside can reduce. Inside to insides can reduce. So if I had 4 over 4 square root of something over square root of something, those 4's would reduce. So inside to inside, outside to outside, you can reduce. All right, see you all back here tomorrow.